today we'll discuss the theory of sets. So in the recent years, set theory has been widely used in economics, particularly in microeconomics, and we'll discuss in short on the basic principles, basic theory of sets, all this. So sets, these are a collection of some distinguished and definite objects. It should be distinguished and definite, that it is countable and enumerable. So those objects or elements, they are known as objects or elements, definite objects and elements, and it is represented by S in these sets. And if 3 is an element of this set, then it is represented like this: 3 epsilon S. That means 3 is an element of the set S. And if it is not an element, then it is represented like this. So if S is equal to 3, 4, 5, it is a set having the elements 3, 4, 5, it is always represented by the second bracket. So 3 epsilon 3, 4, 5, that means 3 is an element of the set, 3 S having elements 3, 4, 5. Now null set or empty set, the set has 0 element. For example, S is equal to 0. That means the elements is 0. So it is called the null set or empty set. Then finite set, elements in this set can be counted one by one in sequence. So the elements will be in sequence and it is countable. It is counted. For example, S is equal to 3, 4, 5. So this counted is 3, 4, 5, and numbers are real numbers, not imaginary numbers, but real numbers. They are not in fractions, so they are real numbers. Then infinite sets or imaginary, infinite or imaginary numbers are in fractions. No n for counting, for example. So there is no n for counting. You cannot count it. Go on counting, there will be no end, just like stars in the sky. No end, and they are in fractions. Now unit sets, it has only one element. For example, say S is equal to this, so only one element is there. Whatever may be the magnitude, doesn't matter, but it is only one element, not 0. If it is 0, it is a null set, and apart from 0, any one element, this will give unit sets. It will form the unit sets. Then universal set, that S1 is equal to P, Q, R and 4. These are the elements in set S1, P, Q, R and 4. In S2, 2, 4, 5, 2, 4, 5. So S union S2, so it is written like this, U. So if we combine these two, S1 U S2 is equal to 2, 4, 5, okay, PQR. So 4 appears twice. 4 appears in S1 also as an element and S2 also as an element. So we'll take one common 4. So 2, 4, 5 PQR. So it is called the universal set. Universal set. So it consists of all elements that belong to either S1 or S2 or both without any repetition. Without repetition. So it belongs to either S1, that means set 1, or set S2 or both. That's why we have not repeated. If we write 4 once, okay, but we will not write 4 twice. Then disjoint set, no common element, intersection is an empty set. So in disjoint set, there is no common element. So for example, set S1, elements are PQR. In set S2, elements are 3, 4, 5. So there is no common element. And here it is 3, 4, 5. Here is PQR. So in disjoint set, it is written like this, the reverse view. So S1 reverse S2 is equal to it is generally pi here. So it is equal to 0. This is the null set. So elements is 0. Since there is no common elements, then we will say it is 0. This is a null set. So disjoint sets are null sets. Then overlapping sets, their union is not empty or null sets. It contains at least one common element. When it contains only one common element, it is the overlapping sets. But it is not empty or null set. At least one common element must be there. So S1 is equal to 7, 8, 9, suppose. This set S1 having the elements 7, 8, 9 and S2 having the elements 5, 6, 7. So common element is 7. So 7 here also, here also. So common element is 7. So it is the question of overlapping sets. So then we'll go for the equal sets. So next is our equal sets. So in equal sets, there are same elements in both the sets. Because S1 is the 4, 5, 3, 7. So these are the elements, 4, 5, 3, 7 elements. And S2, 7, 5, 3, 4 elements. But whatever may be their positions, the elements are same. So there's 3, 4, 5, 7. 3, 4, 5, 7. So set S1 you to set S2. Then another one is equivalent sets. In this case, the number of elements are same. So elements may not be identical, but number is same. For example, S1 4, 5, 7, 3 and S2 P, Q, R, S. Suppose these are the two sets. So elements are not identical. Here it's a 4, 5, 7, 3 and here it is P, Q, R, S. But there are 4 numbers here. Elements are 4. Here also elements are 4. So 4 elements in each set. That's why it is equivalent sets. Then subsets. Subsets. These are small sets of a set. Suppose a class has both boys and girls, students. So it is a set of students, but there will be subsets like girl students, one subset, and boy student, one subset, like that. So if S is equal to 7, 8, 9, these are the elements. Element in subset Si, suppose I8 subset is an element in S. It is written like this, Si included in S. Inclusion. So I is equal to 0, 1, 2 and so on. Now if this is the say, what will be the subset? S naught is equal to null set 0 element, and Sy with 7, S2 subset with 8 element, and S3 subset with 9 element, and S4 again 7, 8, S5 7, 9, and S6 8, 9, and S7 7, 8, 9. So there will be 7 subsets of this. From this set, you can form 7 subsets. So it is represented like this: A subset B, it has less element or equal to the set. So B has less element to B. A may have less element to B or more element to or equal to B. For example, 7, 8, 9, subset 7, 8, 9. So they are equal. So it is a subset, but they are equal. Now proper subset. Subset has a less element or equal to the set A. So in proper subset, we generally do not put this side. So it is U, reverse U. A proper subset B. So it is less element or equal to a proper subset B. Suppose A is a subset with 7 elements, 7 and 8. Okay, and B is a subset 7, 8, 9. B is a set 7, 8, 9. Then A is less, but it includes. It is included in B. Then superset. So symbol is like this. Set A has more elements or equal to set B. Then proper superset. Proper superset. You see, you should remember the sign. No? It is like this in subset, and it is reverse in superset. Set A has more element than set B. As a proper superset, set A has more element than set B. Suppose set A having the elements 7, 8, 9, okay, and B having the elements 7 and 8. So A has more elements than set B. Okay. Then A minus the difference of two subsets, or the difference of two sets. Then relative component. This is called the relative component. Objects belong to A, not to B. This is called A minus B. So if A has the set elements 7, 8, 9, and B B has the element 7 and 8. So objects belong to A, not to B. So what is not there in B? So 9 is not there in B. So 9 belongs to A, but does not belongs to B. So it is A minus B. So with this, we'll conclude today and keep on watching.